Hello students, already we have learned or we have discussed about what is the geometric interpretation of indefinite integral. So what is the geometric interpretation of the indefinite integral? We have already studied. It gives what is that, a family of curves. It gives a family of curves. We have drawn we have taken the function y is equal to x square and we have added constants and we got parabolas with the center, with the different centers. So that gives a family of curves, and also that gives, and after that we have drawn a line which is parallel to, or which it touches all the parabolas. So that means what? The tangents drawn to the curve at the intersection of any line x is equal to a is a parallel, parallel. That also we have drawn. The tangents are parallel. Tangents are drawn to the curves at the intersection point of a line with the parabola. At that point, if we draw the tangent, they are also parallel. So that we have studied these 2 points. You have to mention in the topic. What is that? What is the geometric interpretation of the indefinite integrals? Next, we study some of the properties of indefinite integrals. Properties of some properties of indefinite integral. Some properties of indefinite integrals, not the definite integrals. So which is the first property we can see? The first property is the process of differentiation and integration are inverse of each other. The process of you write the first property, the process of differentiation and integration are inverse of each other. That is, derivative of integral of f of x dx, derivative of integral of f of x dx is equal to f of x is f of x, and integral of f of x dx, integral of f of x dx, integral of f dash of x derivative, they are integral of f dash of x dx is equal to f of x plus c, f of x plus c, where c is any constant, where c is any small f of x, where c is any constant. C is any constant. So this is the first property. The process of differentiation and integration are reverse of each other. So how to prove these? So I'll consider capital F be the antiderivative. I have already told what is antiderivative. Antiderivative in the sense that is definite or indefinite integrals, the integral value of that. So f, I'll consider the antiderivative of f. Let capital F be the antiderivative of f. That is the antiderivative of f. That what is antiderivative? So when we differentiate, we get the f of x. That is when we differentiate that f antiderivative, we get the given function. So that is called the antiderivative. When we differentiate the antiderivative, we get the given function itself. That is the indefinite integral itself, or the given function itself. So if this is the case, then I'll take the integral value both the sides. So what happens if I consider integral value, or then integral of f of x, how I'll write it as, then integral of f of x. Usually we write integral of f of x dx will be equal to f of x plus c, where c is any constant, Now what I'll do is I'll consider the derivative. Here I'll consider the derivative both the sides. This I have considered f be the antiderivative. If it is antiderivative, when we find the derivative of that antiderivative, we get the function itself. And also we know that integral of f of x we have studied already. This will be f of x plus c. Now I'll take the derivative both the sides. Therefore, derivative of integral of f of x dx is equal to derivative of f of x plus c. That means I have considered derivative in both the sides. We have considered derivative in both the sides. So this one we have to get the results. You know what is that result now. I'll rub that. F be the antiderivative also be considered. Next, now we have taken the derivative of integral of f of x dx, that will be equal to derivative of f of x plus c. So this will be equal to derivative of f of x plus derivative of c. Derivative of c means derivative of a constant will be 0. So this will be equal to derivative of f of x plus 0, so that will be, since the derivative of constant is 0. So we got derivative of f of x. Already we have considered f be the antiderivative. If f be the antiderivative, derivative of f of x, we have considered it as a f of x. Therefore, this will be equal to f of x. Will be equal to f of x. So now what is the conclusion? We have taken derivative of integral of f of x dx is equal to, we got the result as f of x. So this will be derivative and integrals cancelled, and we got only f of x. So this is the first implication. Similarly, we can write we know that integral or f dash of x means what? Derivative of f of x. We know that f dash of x means derivative of f of x. I'll take integral value. Integral of f dash of x dx. Integral of f dash of dx is equal to, again by the same procedure, I have taken f dash of x is equal to derivative of f of x. Then I'll consider integral of f dash of x dx is equal to integral of d by dx of f of x. So that will be integral of derivative of this. I can take it as f of x. Integral of that will be we get it is f of x. F of x plus c we have to write, because everywhere we have to add constant. So plus c, where c is a integral constant. So we got integral of derivative of f of x. Integral derivative of f of x will be f of x plus c, and derivative of f of x dx will be f of x. So this is the result where c is any arbitrary constant. So this is the one property of indefinite integral. Next property, if there are two indefinite integrals, is the first property. Next one, if there are two indefinite integrals of having same derivative, then it represents a same family of curves. We already know that integral value represents family of curves. Therefore, if there are two indefinite integrals with the same derivative, then it lead to, or it gives the same family of curves. So they are equivalent. So write this property number 2. Two indefinite integrals with the same derivative. The same derivative gives the same family of curves, and they are equivalent. So that is the second property. So how to prove this? We have to consider two functions. Second property proof. Let f and g be two functions, be any two functions, and here it has the same derivative, two indefinite integrals. So here we have to f and g are functions, but these are indefinite integrals, means integral of f of x dx is equal to, or integral of they have same derivative, means integral of f of x dx is derivative of that. So derivative of integral f of x dx is equal to derivative of integral of g of x dx. They are equal because two indefinite integrals having same derivative, therefore the derivatives are same. I have considered these are the two indefinite integrals having same derivative. Next I can write it as, both are derivative, means I can write the same derivative. So derivative of integral of f of x dx minus integral of g of x dx, so that will be equal to 0, because I have taken all the terms one more, so that will be equal to 0. So this one we got now. Then after that, what we can write is, now the derivative, so here will be 0, means I have to find the derivative for this one, and here it will be a constant. So this implies integral of f of x dx minus integral of is equal to, have taken something will be derivative of something will be 0, in the sense what, this will be constant, this will be a constant. Why it is? Because derivative of something will be 0, in the sense that function will be constant function. So C is any constant. C is any constant. So now we got integral of f of x dx minus integral of g of x dx equal to C. Therefore I can write integral of f of x dx is equal to integral of g of x dx plus C. So that means it is a, we know that integral always represents a family of curves. So here integral can be written as integral of one more, in the sense, so integral of f of x dx plus C1, and so the families we get. So this is one family of this is one family. So these two families are equivalent now, these two families are equal, and what is that we have, they have the same set of families. So this is one family, this is one more family, so both the families are equal, in the sense, either I can write f of x dx equal to this integral of f of x dx is equal to integral of g of x dx plus C, or I can write integral of g of x dx is equal to integral of f of x dx plus C, or minus C can also be written. That means what, both are the families, both the families are same, both the family we know what is a family, so it gives a family of curves, same curves with the different vertex. So this gives the same family of curves, and they are equivalent. Why they are equivalent? Because they are equal, therefore after this what we have to write, therefore either f of x or g of x both are the families, therefore the family can be written as, I'll write, therefore family of integral of f of x dx plus C1 is a, C1 belongs to real number, and integral of g of x dx plus C2 is a real number. So these two are therefore these two represents a same family R represents same family and they are identical. The families are identical. These two families are identical. So this is the second property. Next property. So if we know that derivative of f of x plus g of x can be written as derivative of f of x plus derivative of g of x. Therefore, integral of f of x plus g of x also can be written as integral of f of x and integral of g of x. Integral of f of x and integral of g of x. Third property, integral of f of x plus g of x dx can be written as integral of f of x dx plus integral of g of x dx can be separated. So we know that from the first property what we can write, derivative and integrals are inverse to each other. Derivatives and integrals are inverse to each other. Therefore from property 1, from the first property we can write derivative of integral of f of x plus g of x dx. Derivatives and integrals. Now the integrand will be f of x plus dx. So derivative and integral cancels and we get f of x plus g of x. F of x plus g of x. So the integral and derivative inverse, so that can be cancelled. And also we know that, or we can find that derivative of integral of f of x plus integral of g of x is equal to, if we already studied in the derivative chapter, derivative of integral of f of x dx, derivative of integral of f of x dx plus integral of g of x dx. We are calculating the derivative of these. So this can be calculated. Derivative first one, derivative of integral of f of x dx plus derivative of integral of g of x dx. Derivative of sum can be written derivative first one plus derivative of second one. So now when we can see here, this will be integral and derivative can be cancelled. We get it is f of x plus g of x. F of x plus g of x. So I will consider this as A and this as B. So when you see A and B, when we see the A and B, so what we get when we see A and B? From the A and B, we got this side, this derivative of integral of f of x per dx can be written as derivative of integral of f of x dx plus integral of g of dx, or we can write, and also we have written and we know that derivatives, what is that, two functions having same derivative. Now this also f of x dx, this also f of x dx, that means two functions are having same derivative, then it represents same family, it represents the same family. So now the derivatives are same in the sense these functions are also same. So from property 2 we can write, from property 2, this is from the property 1, from property 2, from property 2 and from A and B, from property and from A and B, so what we can write, integral of f of x plus g of x from property 2 and from A and B, we got integral of f of x g of x dx will be integral of f of x dx plus integral of g of dx. So this is property number 3. Next, property number 4. Next property. So we know that derivative of k, a constant into function, we can write it as a constant into derivative of the function. Similarly, we can write integral also. For any real number k, for any real number k, we can write integral of k into f of x dx can be written as k into integral of f of x dx, k into integral of f of x dx. So how to prove this? So we have the property, first property as differentiation and integration are inverse to each other. Therefore from the property we can write it as derivative of, from property 1, from the first property we can write derivative of integral of k into f of x dx, integral of k into f of x dx can be written as k into f of x. Why integral and differentiation can be cancelled each other, can be cancelled in the sense they are inverse to each other. And also we know that derivative of, also we know that derivative of constant into function, constant into, if I consider that function as integral of f of x dx, derivative of constant into function, if I consider that function as integral of f of x dx, then that will be equal to constant into derivative of the function. Constant into derivative of the function. So what is the derivative of the function? It will be a d by dx of integral of f of dx k into d by dx of integral of f of x dx. So derivative and integrals can be cancelled because they are inverse to each other. Therefore I can write it as k into f of x. So I can write that as k into f of x, k into f of, so this is also k into f of x and this is also k into f of x. So we can write again, this is a and b. From a and b we can write these two are equal. That means what? The functions having same derivatives. If the functions are having same derivative, this also indefinite integrals having same derivative, then that represents what is that, a family of curves. Therefore from property 2 and from A and B together, from property number 2 says if two indefinite integrals are having same same derivative, then that represents the same family of curves. So now since k into f of x are equal, the left hand sides are equal, so these two are equal in the sense derivatives are same. If the derivatives are same in the sense, then it represents same family of curves. From 1 and 2 and from the property 2 we can write integral of k into f of x dx, integral of k into f of x dx is equal to k into integral of f of x dx. K into integral of f of x into dx. So this is one more property, fourth one. If it is k, integral of k into f of x dx, I can write it as integral of k into f of x dx. So next property, fifth one is the same, not like this. So if there are only one function, I can write it as integral of k f of x is f of x dx is what, k into integral of f of x dx. If there are many functions, like from property what is that, 3 and 4, combining from property 3 and 4, we can write, if there are finite number of functions from property 3 and 4, if there are finite number of functions that is f1, f2, f3, so on up to fn, and the constants and the real numbers k1, k2, k3, so on up to kn, then if it is so, then integral of k1 f1x plus k2 f2x, plus k3 f3x, so on up to kn fnx whole thing into dx is equal to k1 into integral of f1 x dx plus k2 into integral of f2x dx plus k3 into integral of f3x dx, so on up to kn into integral of fnx dx. So this is the next property. If there are any number of terms also, we can write same from using property 3 and property 4. So these proofs are not important for any property, only the result is important. Then already we have named what is that, integral value we have named, that is what, antiderivative also. So by calculating the antiderivative in the sense, that is the integral value. So how we can calculate? By thinking what is the previous, so what is the actually, so when it is a derivation means what? It is the what is the value we get after derivation. So when we integrate the derivatives, we get the function. Therefore, by thinking how to what is the antiderivative, how for what function, so given function is the derivative. So that is the method of finding a antiderivative, that is called the method of inspection. So the search of function for finding an antiderivative is known as integration by the method of inspection. So here we search what is the for a given function, that function is a derivative of which function. When a function is given, we have to find out, so a given function is a derivative of which function. So what is that? That way of finding integration is called the integration by the method of inspection. So that is one more very important method, integration by inspection. So not by directly by using the formulas, by thinking. So what is the actually derivative, such that we have got the integral, we got the integral. That is called the inspection, method of inspection. So these are the types. So using method of inspection and some of the basic formulas what we have studied, using that we can solve many problems that we solve in the next class. Thank you.